I'm going to rewrite the integral to select to a different form. Okay. To sine of x squared, you put that in brackets. And by the way, it's kind of essential to put that function in brackets. Okay. Or otherwise the notation could be confusing, right? The definite integral from 0 to square root of half pi. Right. The way to choose u is the same. The way to choose u is the same. Now the integrand is the product of two functions. Choose u as a function of x, so that one function becomes a function of u with the easy to compute antiderivative. The other factor is the derivative of u times a constant. The way to choose u is the same. So because we just did the corresponding indefinite integral, right? So you know how to choose u. So choose u to be x squared, right? You know how to get antiderivative of sine of u. So the other factor is the derivative of u times a constant, right? I told you only one additional step. The next step is the same thing. You compute du, the differential of u. The differential of u du is 2x. You differentiate the function, right? And then times dx. I told you there's only one additional step. I still put the other function together with dx in the box. Okay. When you actually do the question, that's your imaginary box. We still solve the equation for the box from the differential. Now, in next step, we want to rewrite the integral entirely in terms of u. Okay. In the given integral, this is x value. So that makes sense? This is x value. I told you earlier, in the new integral, I want you to write everything in terms of u. This time, everything is going to be in terms of u, including the lower limit and upper limit. So basically, we are going to convert these x values to u values, so that the new integral is going to be completely in terms of u. Okay. To make the meaning clear, it's not essential to do that. In the given integral, I'm going to write x equals 0 in here to mean the lower limit is a value of x. I'm going to write x value of x equals square root of half pi in here to mean the upper limit is a value of x. You do not have to do that. It's not essential. If the function is a function of x, by default, these two numbers mean x values, right? Now we need to convert these numbers to u values so that the new integral is going to be entirely in terms of u, including the lower limit and upper limit. So by that we mean we need to get the u value for x value of 0. 0 is coming from the lower limit. When x value is 0, so what's the u value? Anybody want to tell me? The relation between u and x is here. X value of 0 implies, that's the standard notation saying implies. X value of 0 implies u value. The relation between u and x is here. Okay, u is x squared. When x value is 0, u value is 0 squared. So which is 0. Okay. Right. Again, that's u value for the x value of 0. later on when converting the new integral to a new integral, we need to have that as a lower limit. Right? And likewise, we need to get the u value for x value of the upper limit, which is square root of half pi, I think. Square root of half pi. When x value is square root of half pi, it gives you the u value of so basically you take the square of x value, you get the u value. It's easy, right? U value is equal to half pi. So that makes sense. Now in next step we want to write everything in terms of u, okay, including the lower limit and the upper limit. So can I just continue from here? So here I'm using these notations to indicate these are x values. Okay. Now I'm going to write everything in terms of u values. We'll do the new thing later, but this function now becomes sine of x squared. Sine of x squared in terms of u is sine of u, right? The stuff in the box is half of du. Half of du. I'm going to put the constant factor for the integration notation. Okay. And what? Anybody want to guess the lower limit? The new lower limit? That's a new that's a new integral of u. These two limits, lower limit and upper limit, are supposed to be u values, right? This is the only question I'm going to use u equals 0. I think some people do use a notation like this, but I'm trying to say x value of 0 will become u value of 0, and the x value of square root of half pi will become u value of here, right? Half pi. That's the only new thing. The new thing is you need to get the u values for x value of the lower limit and the upper limit. Okay. Okay. Again, the answer to a definite integral is a number. We are looking for a number. I forgot to mention one other thing. To evaluate indefinite integrals, you need to write the final answer as a function of x and then plus c, right? But for the definite integral, after using the substitution rule, you do not go back to x. You just evaluate a new integral of u. At this point, you forget about x. Okay, you just evaluate the new integral of u. What I meant is, do not go back to x. You just imagine that's a new question. Okay, you do the new question from here. So you have 1/2 in here. Get the antiderivative of the integrand, so which is negative cos of u, I believe, right? I should have used square brackets, so but it doesn't matter. Okay. And then you put in the upper limit of 1/2 in here. Okay. And then put the lower limit of 0 in here. Okay. Probably you want to write u equals 1/2 u equals 0. To be consistent. So with these notations. Okay. And then you plug in numbers, you can have the answer. Okay. Again, so do not go back to x. That's a new integral of u. Everything is already in terms of u. You just get the final answer. Okay. I think you have 1/2 of plugging upper limit. I think you have negative cos of half pi, right? And then minus negative cos of 0. I think the final answer is 1/2. Is that right? cos of 0. Again, cos of 0 is equal to 1. Cos of half pi is 0. Okay. So that's the whole story about the substitution rule for the definite integral. Okay.